Right, so this lesson about 8.3 mechanics, we look at variable acceleration in one dimension. So let's do a quick recall. First of all, if the motion is under constant acceleration, so motion is under constant acceleration, we use Suvat. Or Ruvat if it's a vector, 2-dimension. But if the motion is under variable acceleration, it's given as an expression, then we use differentiation or integration. A short term will be calculus, which essentially means differentiation or integration. Okay, right. So there are three main variables in Suvat. The first one is about distance. The second one is about velocity. And the last one is about acceleration. Now, I deliberately write in this format because when you show if we're going that way, downwards, it's about differentiation. And going upwards, it will be integration. Now, how do you remember the formula? Well, it's actually quite easy. So if you set it up like this, then what you can do is, so from distance to velocity, the end of the arrow will be the start of the formula. So the arrow is on a v, so v equal, okay, you want to differentiate, so ds by dt. We know distance, we're going to use s, v, and a. And next one, similarly, the arrow is pointing towards a, so a equal dv by dt. Going backwards from a to v, to get v, so the arrow is pointing v again, so v equals the integral of a dt. This one is s equals integral of v dt. So you've got 4 formulae to remember. Okay, right. And why do we have variable acceleration? Is because if you think about in real life, no one's going to apply the brake, you know, very hard. Well, when we apply brake, you know, when we apply the brake, let's say driving, we're going to apply gradually. So our deceleration will be gradual, or when you accelerate, it won't be 5, 10, 15, 20. You know, it's going like 5, 6, 8, 12, 13, and then 25, and then 70, for example. But yeah, so that's why we have a curve rather than sometimes variable rather than constant. Constant is like an ideal situation. That's how we can model things. But variable acceleration is more like a real life. Right, so example. A particle is moving in a straight line with acceleration time t second given a equal cos 2 pi t meter per second squared. By seeing this, you know this is variable acceleration. Okay, so variable acceleration. Constant acceleration is when you see a equals 5, a equals g, a equals 6, a equals -3, a number, a constant. Well, yeah, constant acceleration, right? Next one. The velocity of the time of the particle at time t0 equals 0 is 1/2 pi meter per second. Find an expression for the velocity at time t seconds. So to find v, I'm given a, so I'm going to use v equals integral of a dt. Now, here's a little tip for you. If I want to find v, my formula must start from v equal. Okay, so you're not going to use dv by dt because I need to find velocity. So you've got 2 options. One, v equals ds by dt, or v equals the integral of a dt. I'm given acceleration, so I'm going to use v equals the integral of a dt. So I need to integrate the cos 2 pi t dt. To integrate cos 2 pi t, you will need reverse chain rule. So to do reverse chain rule, you need to think about, I'm not going to go through how to do reverse chain rule because you should have done this in integration chapter. You would have got v equals to, so integrate, yep. So it will be 1/2 pi times sine 2 pi t. But when we integrate, we have the plus d, our forgotten child. So that's the answer. Okay. Right. Oh, actually, that's not the answer because when you find c, so that's not the answer. So when that we need to substitute a boundary condition. It means when t0, we're given when t0, the velocity is 1/2 pi. So when t0, v equals 1/2 pi. This line is to help you to find the c value. You should have done most of these back in year 1. Okay, mechanics to find c. So when t equals 0, v equals 1/2 pi. So 1/2 pi, we sub it in. 1/2 pi times sine 0. Sine 0 is 1. Sine 0 is 0 plus c. So 0. So c equals 1 over 2 pi. Therefore, the velocity equals to 1 over 2 pi sine 2 pi t plus 1 over 2 pi. And that's the answer. Part B, find the maximum speed. To find a maximum speed means in terms of differentiation. So it means, so if I want to find, for example, here's the, okay, here's an equation. I don't know, let's say x and y, right? If I want to find a maximum value of y, that means that's a stationary point, the maximum, I would do dy by dx equals 0. In this case, to find a maximum speed, I would do dv by dt equals 0. Okay, so dv by dt equals 0. So I will need to differentiate, okay, what we've got from part A. So differentiate that 1 over 2 pi is just a constant, so I'm going to do a 1 over 2 pi. To differentiate sine 2 pi t, I use chain rule. Differentiate outside, that's cos 2 pi t. And then differentiate inside, the 2 pi t will give you 2 pi times 2 pi. Plus differentiate 1 over 2 pi is 0. And that equals 0. 2 pi and 2 pi cancel out. So cos 2 pi t equals 0. I can inverse the cos, so 2 pi t equals inverse cos of 0. Inverse cos of 0 is pi over 2. Yeah, pi over 2, pi over 2. So divide by 2 pi. T equals to divide by 2 pi. So if I divide by pi, the pi will cancel out. Divide by 2 will be a quarter. So t equals a quarter. Yep, t equals a quarter. So if t equals a quarter, to find the maximum speed, I will substitute back into the v equation to find the maximum speed. So to find the velocity, that means the maximum velocity happens when time equals pi, when time equals 1 over 4. So sub it in. So I sub it. So I'm going to substitute t equals a quarter into v. So v equals 1 over 2 pi times sine 2 pi times a quarter plus 1 over 2 pi. If I simplify sine pi over sine 2 pi times a quarter, that should give you 1. So that's 1 over 2 pi plus 1 over 2 pi. That gives you 1 over pi. If you don't know why, because, well, a half, think of it, a half plus a half is just 1, but pi is underneath it. Or you can use decimal, 0.318 meter per second. Okay. Is there another way you can work it out? Yes, you can. I'm going to explain a different way to work out maximum speed. Now, this is optional. To find the maximum speed, we know this is a constant. This bit, if you remember Pure 2 chapter 7 about maximum and minimum value of sine and cos, we know this value has a minimum of -1 and a maximum of 1. This is a constant again, so we can't change it. So to find a maximum overall, the sine 2 pi t, I can make it into 1, because to find a maximum, if I put a -1, I get a minimum. If I put a 1 in there, that will give me the maximum. So a constant means we can't change the value, but this sine 2 pi t has a range of values between -1 and 1. By substituting a value between -1 to 1, it will give us a range of answers to v. Because you can imagine if I start to substitute -1 and then minus 0.9, minus 0.8, up to 1, you get all kinds of values of v. To find a maximum, the biggest out of it, you substitute 1 into this. And 1 over 2 pi times 1 plus 2 pi becomes the same step in here. All right. Part C. So what's part C? Part C is find distance traveled in the first 3 seconds. To find a distance, that means I need to use S. Well, to find S, I only have one equation, the integral of v dt. So S equals the integral of v dt. So S equals integrate v. What's v? V is 1 over 2 pi times sine 2 pi t plus 1 over 2 pi and dt. Well, I want to find a distance from first 3 seconds, so I'm going to put a limit from 0 to 3. Right? So how do we integrate that? Well, one, you can integrate this with a calculator because we've got a range, but you also need to show how to work it out as well, marks. So you can use a calculator to double check your answer by putting the full thing in there. But if you want to integrate separately, so integrate, so 1 over 2 pi is just 1 over 2 pi. So integrate sine 2 pi t will be times 1 over 2 pi So integrate sign is negative cos, so it's negative cos 2 pi t. Integrate 1 over 2 pi is 1 over 2 pi times t. There's no plus c, we don't need a child. For once, we'll put 0 and 3 in there. So if you put 3 in the equation, you get, so s equals to 1 over 2 pi times 1 over 2 pi. Now you can put this in the calculator. Cos, negative cos 2 pi times 3 is 6 pi plus 3 over 2 pi. Subtract, put a 0 in there. 1 over 2 pi times 1 over 2 pi, negative cos 0. Now don't assume the whole thing is 0 just because the value of t substituting is 0. Because when you do cos 0 is 1 plus 0 over 2 pi. Plug it all in, you should get s equals, you can pause the video, plug it in, see if you got the correct answer. It's actually a skill to put a calculator accurately. Okay, as opposed to a lot of students thinking, putting a calculator is easy. If you ask a year 7 student, do you want a calculator, do all the exams? Of course, they would want a calculator. Why? Because their mental maths is not good. Unlike us, our mental maths are quite good, but just not reliable. Okay, right. Next one, 8 point. Next one, carry on. Example: a particle of mass 6 kg is moving on the positive x-axis. At time t second, the displacement from the origin is given by, we've got an equation here. Once the equation, you know it's about differentiation integration. Like this, a function of t is about integration differentiation. Find the velocity of the particle when t equals 1.5. So when t equals 1.5, so 1.5 velocity. So we're given s, so v equals ds by dt. So we want to differentiate s, which is 2t to the power 3 over 2 plus a third e to the power minus 2t. To differentiate that, you should have known, you multiply by the power, so 2 times 3 over 2, power minus 1, a half. And then to differentiate powers of e, you just multiply the coefficient, the power of e, which is minus 2, so minus 2 over 3, e to the power minus 2t. And then we're given when t equals 1.5. Let's simplify that a little bit first, shall we? So v equals 2.5 cancel out, 3t to the power of a half minus 2 over 3, e to the power minus 2t. When t equals 1.5, sub it in, v equals 2, 3.64. On your calculator, you should get 3.64. Okay. Hopefully there isn't any issue. This is more like a, year 1 stuff, but they give you harder terms to differentiate, combining what you've learned in year 2 differentiation, right, and integration. Part B, given the particle is acted on by a single force of variable magnitude F Newton, which acts in direction of positive x-axis, find the value of F when t equals 2. Tell me the one and the only equation you've learned about force. F equals ma. To find force, okay, I must know m and I must know a. I know the mass, which we're told is 6 kg, but we don't know a. So guess what? We want to find a. So how do you find a? In calculus? Well, you guess it right. So part B, let me show you. So F equals ma. We need the a first. So how do you find a? So a equals integral of b. A equals dv by dt. That's our first step. So that's the thinking behind it. Okay, I see a variable acceleration question. I know something to do with differentiation integration. Part B is asking me for force, and the only thing about force I know is F equals ma. So I'm going to do F equals ma. I realize I need a, so a equals dv by dt. So let's differentiate v. So differentiate v. 3 to the power of a half is 3 over 2. T power of minus 1 is minus a half. Times minus 2 again, so it becomes positive 4 over 3 e to the power of minus 2t. And then, when t equals 2, put in a calculator, a equals 1.09 meter per second squared. So F equals ma. F equals 6 times 1.09. F equals 6.51 Newton. Voila. Okay, nice and straightforward. Next one, a little bit more complicated. This question is 7, 8, 15 marks, especially last part, we'll see why. Example, the particle P moves on the x-axis at time t second, the velocity of p is v meter per second in direction of x is increasing. It's like this. So this is a discontinued function, the two parts. Okay, it's like we walking speed depends on different scenario. When your mom is asking you to do housework, or when you know it's time to do some homework, you run faster. Okay, if you know you've got time to do your own stuff, Netflix, console gaming, hang out with friends, you walk extremely, even faster. Yeah, even faster to meet your friends, or just dash to the sofa to do whatever you want to. Right. Anyway, nonsense over. When time is 0, p is its origin. Now this is very, very, very important. The reason is because this essentially, when t is 0, the displacement is 0. This is a hidden information, right? This is a hidden information. Find the greatest speed of p when in the interval 0 to 4. Now, to find the greatest speed, what you want to do is you will find, well, dv by dt, don't you? So question A, so to find the greatest speed, dv by dt. So dv by dt, let's differentiate greatest speed. So greatest means stationary point maximum. Differentiate, so when t is between 0 and 4, that means we use the first equation. 10 minus 3t to the power half, and that equals 0. So let's go and solve it. 10 equals 3t to the power half divided by 3. 10 over 3 equals t to the power half. How do I get rid of power half? I square on both sides. So t equals 10 over 3 squared, which is 100 over 9. So 100 over 9 is 11.1. But, so 11.1. So what's the problem here? The problem here is that's outside the range of 0 to 4. So how do you work it out then? Well, then that's where you try to put in numbers in there. So you can try putting 0 and 4 in there. So if you put, so therefore we can't accept that t equals 11.1. So when t equals 4, when t equals 0, we'll substitute in there. When t equals 0, b is 10 times 0 minus 2 times 0 to the power of 3 over 2, is it? 3 over 2, yep. And you should get 0. When t equals 4, b equals 10 times 4 minus 2 times 4 to the power of 3 over 2, which is 24. Now, because when differentiate find the greatest speed, t is 11.1. Therefore, we're happy just to go with 24 because we have to be in range of 0 and 4. That's the maximum speed, 24 meters per second. Okay, now all differentiation part is required. That's why 4 marks, just to verify that there's no greater speed between 0 and 4 in here. Right, question B. Find the distance of P from O when T equals 4. To find distance, guess what? We want to find S. Yeah. So part B, find S. So S equals, we're given B, dt. We're asked in the first 4 seconds, so from 0 to 4. So let's integrate 0 to 4 of 10t minus 2t to the power of 3 over 2 dt. So S equals, integrate that. I trust you know how to integrate, so I'm not going to go through that. And 4, put in a calculator, you get 54.4 meters. 2 marks, right? C, find the time at which P is instantaneously at rest for t greater than 4. Instantaneously at rest means the velocity equals 0. We are asked when t greater than 4, so we have to use the second equation. Okay, 24 minus, so part C. Instantaneously at rest means B is 0. So I have to make the second equation equal 0. 24 minus t minus 4 over 2 to the power of 4 equals 0. Let's bring the second term to right hand side, make it positive. So 24 equals t minus 4 over 2 to the power of 4. Next, to make t a subject, I need 4th root of 24, and then times it by 2, and then plus 4 equals t. So plug in the calculator, t equals 8.43 seconds. I put in 3SF. Right. Now, this time is very important for us to do part D. You wonder why is it 7 marks, right? Find total distance traveled by P in the first 10 seconds of its motion. Now remember, we've got when t equals 8.43 is instantaneously at rest. What it means is when a car, okay, think of it now, this doesn't quite happen in real life, but this what happens in this question. When a car travels, okay, in here a certain point, when t equals 8.43 seconds, the car stopped. So at 4 seconds, remember when t equals 4, we're traveling 24 meters per second. But somehow when t equals 8.43, we stopped. What does that mean? That means we're slowing down. Now in mechanics world, once we slow down, what happened? When velocity becomes 0, now imagine we're going more slower and slower, 24 becomes 0, then surely it becomes negative. Now in negative speed, negative velocity in mechanics means we're going backwards. Okay, so we're going backwards. That means when t equals 10, the car will be somewhere in between. The question wants to find distance, not displacement. Distance means you want to find the distance in here, let's say d1, and then d2 in here. Obviously, we have t equals 0 as well in the beginning, which is 0 meters per second. Okay, and that's distance as well. Okay, so let's call it d1, d2, and d3. That's the total distance, right? So that's why one thing we can't do is, that's why it leads us to the conclusion that we can't do it from 0 to 10. Okay, why? Because one, there are two equations from 0 to 4 seconds and 4 seconds to 10 seconds. But two, the distance from 4 seconds to 10 seconds has been broken to 2 parts. It should be from 0 to 4 plus 4 to 8.43 and then plus 8.43 to 10 seconds. That's the way to go. Okay, if you have seen the Drake meme about what's not, what you should be doing, what you shouldn't be doing, the one that he has his hand covering his face, that meme. So that meme, you want to cover his face for this one, and then you're pointing fingers to get his approval on this one. Right. So how do we do that? Well, the first bit, distance 1, we already know distance 1. So if I draw a roadmap, it means at time t equals 0, so t equals 0, t equals 4, t equals 8.43, and t equals 10. Now we found the distance from part B. This 54.4 meters. This comes from part B. Okay, so what we need to find is the distance here and distance here. Well, I'm going to call distance 2 and distance 3. So to find distance 2, I need to do s equals integral 4, 8.43 of 24 minus t minus 4 over 2 to the power 4 dt. To integrate this, 24 will give it 24t. To integrate to power 4 in here, it will becomes power of 5, and then divided by 5. Actually, t over 2. Yep. Okay, what I'll do is actually, what you should be doing is, I can take out the 2 first. So it will be 1 over 2 to the power 4 times t minus 4 to the power of 4 dt. So what I've done is I've extracted a half out of the bracket. I haven't done any integration yet. Next, to do integration, then I can do that. So 24t minus that 1 over 2 to the power 4 has nothing to do with it, times t minus 4 to the power 5 divided by 5 for 8.43. Plug in the calculator, you should get s equals 85 meters. Do the same for distance number 3. The distance number 3 is s this time from 8.43 to 10 of 24 minus t minus 4 over 2 to the power 4 dt. We've done the integration already from the previous part, so we can just write s equal 24t minus 1 over 2 to the power 4, t minus 4 to the power 5 over 5, and 8.43 to 10. So sub in 10, and then sub in the 8.43, what you realize is that displacement is negative 38.2. Negative makes sense because we're going opposite direction. So the negative, when it comes to distance, we can ignore it. So the total distance is going to be 54.4 plus 85 plus 38.2. We can ignore negative, and you get 177.6 meters. That's the hardest part about this question. And they give you the hint from part C, instantaneously at rest. So we know when you say instantaneous at rest, it means they're changing direction. Changing direction means we have to break it into two parts when it comes to integration, when we find the distance. Okay, I hope it's not too difficult in here. In terms of concept, I think it takes time to adjust. But in terms of calculation, the integration part, if you struggle with the integration here, you should go back to the integration chapter in pure maths. Okay, all right, and that's a chapter about variable acceleration. We use calculus. Remember these four formulae. Okay, one last tip. If I want to find V, I use the V equal. Depends what information is given. If I want to find A, I'll do A equal. If I want to find distance, I'll do S equal. All right, thank you.